Hello and welcome to Education at SSPJ online video tutorials. We are in the chapter number 6 of class 8th, Combustion and Flame. We'll continue with the discussion on question and answers of this chapter. In the last few videos, we were doing the same, and here we go for next NCERT textbook questions. This is a very important question. Make a labeled diagram of candle flame. If it comes in the exam, then it may be of 3 to 4 marks. So you need to require to understand what are the different parts, or we call it as zones of candle flame. Well, let us draw zones of candle flame. Zones of candle flame. Right? So when you draw this, you have to properly label it. So let us discuss on that. Let us draw the flame first. So what I do is I'll take an innermost layer of the flame and then draw a center layer and then a outside zone. Okay, when I call a layer, it's a zone. Okay, and then it's a thread, and that is over a candle. So you can just show it as a candle. Well, now the outermost part of this flame is called outer zone. In outer zone, complete combustion is possible. So here, complete combustion. And why here complete combustion? It is more exposed to oxygen outside. Okay, easily available. We know that for burning, for combustion, oxygen is required. So it is required more in quantity. So more the oxygen, so better the combustion process is. And therefore, this part is hottest part. Now the next zone is middle zone. So we will label it as middle zone, where there is partial combustion is possible. And why there is a partial combustion? What do you mean by partial combustion? Partial combustion in the sense more of oxygen is not available here. So whatever substance is there is not completely burnt here in this zone. Therefore it is partial combustion. Right? And it's not so hot and not so cold. So we can refer it as moderately hot. And the last one, it's the least hot, and that is what called innermost zone. And there is more of unburnt wax is available. And why more of unburnt wax? Because less of oxygen supply here, being this as the innermost zone. So generally it appears black in color, whereas it's bluish. Bluish is an indicator of hottest zone. There will be more of temperature. You can very easily test it. You can take a paper or a metal sheet and then keep over here, keep over the flame. If this is a flame, so you can keep over the flame like this, and then you will find bottom of this, on this side you will find a carbon which is formed, carbon rings which are formed. Right? And what does this carbon ring suggest? These are the unburnt particles. Right? So this is what the answer you should draw and label it properly for the question. Draw zones of candle flame. So that will carry 4 mark. Next question. Name the unit in which calorific value of a fuel is expressed. So before we write answer straightway here, we'll once again revise what is calorific value. Calorific value is an amount of heat given out by a combustible substance or a fuel, right? So fuel gives heat. If 1 kg of fuel if you take, how much of heat it comes out of after burning that fuel is what called calorific value. Let me tell you once again. Calorific value of a fuel is the amount of heat given out after the complete combustion of 1 kg. 1 kg is very important. 1 kg of a fuel. So please refer previous videos. Now, since it is per kg, right? So this is per. So since it is per kg, that is per 1 kg, or we can even write per kg, the unit of heat is kilojoules. So kilojoules per kg. So what we write, this is kilojoule is unit of heat, and this much of heat is given for every kg. So together it is kilojoules per kg. Let me tell you once again, kilojoule is the unit of heat, that is energy, right? Because heat is a form of energy, and this much of heat is coming out for every kg, and that all together is the unit of calorific value. So please remember, unit of calorific value is kilojoules per kg. We'll go for next question. This is the answer of is kilojoules per kg. So when you write here kilojoules this way, you have to read it as kilojoules per kg, right? So next question is, explain how CO2 is able to control fire. Okay, this also we have discussed in the previous videos. However, we'll see what is the answer is, and the answer should be in point. But in general, why CO2 is used? Because we know that combustion requires, fire requires oxygen to support a fire, right? So if you disconnect oxygen from fire, then fire will get off, right? So that work is done by carbon dioxide. Carbon dioxide is heavier than oxygen, right? So what happens, because of this property, if there is a fire, let's say this is a fire on certain substance here, okay, and you pour carbon dioxide gas over it, and it is already taking oxygen in the surrounding. So what happens, carbon dioxide goes down because it's heavier, and when it goes down it makes a blanket over it, a blanket of carbon dioxide. So this you can call it as a blanket of carbon dioxide. So it creates an envelope of carbon dioxide or a blanket of carbon dioxide around it, and the oxygen will get cut off, which is a supporter of combustion. That's how it controls fire. Okay, so how will you write? You have to write in points. Carbon dioxide, being a heavier than oxygen, covers the fire like a blanket, right? Since the contact between the fuel and oxygen is cut off, the fire is controlled. The added advantage of carbon dioxide is that most cases it does not harm the electrical appliances. Therefore, the carbon dioxide is used. This is what the explanation. Now next question. It is difficult to burn heap of leaves, green leaves. Now green leaves, heap, okay. So this is a green leaves, green leaf. But dry leaves catches fire easily because of the water content. So how does that water which is there in the green leaf, okay, if you compare to a dry leaf has no water or a minimum amount of water. It's very dry, and when it is dry it can be easily burnt. Now for burning we require ignition temperature. So any substance to burn, it reaches to a temperature, and that lowest temperature is called ignition temperature. Please remember this. Now water doesn't allow this green leaf to reach its ignition temperature, and therefore unless it reaches its ignition temperature it will not burn. So therefore it is difficult to burn a heap of green leaf, but once it is dry then it is easily can be burnt because it reaches its ignition temperature. Water stops a green leaf to reach its ignition temperature. So the answer can be the green leaves contain some water, due to which green leaves do not reach their ignition temperature. Therefore they do not catch fire easily, while dry leaves have no water. So they reach their ignition temperature faster and they catch fire easily. Next question, which zone of flame does a goldsmith use for melting gold and silver, and why? So melting of gold and melting of silver, we require high temperature, right? Otherwise they will not melt. Melting means converting from a solid state to liquid state. Now as we know, every flame has three zones, right? The outermost zone is called a blue zone, right? It's the outer zone. Now in between there is a zone that is called a middle zone, and the last we have innermost zone. Now remember, more of oxygen from outside is available to the outer zone, and that is why outer zone is hottest. Complete combustion takes place in this zone, whereas in the middle zone partial combustion takes place and very less combustion takes place here in the innermost zone. So here more of unburnt particles will be there even in the middle zone, and therefore since the outer zone is hottest among all the three zones, it is always good to use outer zone for melting of gold and silver, right? So the answer can be a goldsmith uses outer zone, that is the non-luminous zone. It will not appear in a yellow color, it can be a bluish, like in a LPG cylinder gives a kind of blue zone, right? It's of that color of a candle flame to melt gold and silver because it is the hottest zone and has more temperature, right? Now next question, in an experiment 4.5 kg of fuel was burnt completely. So there was a fuel, right? There was a fuel, and what is the weight of fuel? 4.5 kg, and when it is completely burnt, the heat produced was 1,80,000, right? 1,80,000 kilojoules. So what is a kilojoule? Unit of heat, right? So this much of heat energy is produced after burning 4.5 kg of fuel. Calculate the calorific value. It's very simple. And what is calorific value? Calorific value is the amount of heat given for 1 kg. Okay. Now 1,80,000 kilojoule of energy is given out for how much of kg? 4.5 kg. So we can write here for 4.5 kg gives how much of energy? 1,80,000 joules, kilojoules of energy. So by definition we have to find out for 1 kg. So it will be very simple calculation, 1,80,000 divided by 4.5, and that will give you 40,000 kilojoules. Understood? And this 40,000 kilojoules is, when you write 40,000 kilojoules, if you write per kg, then that is the calorific value of this fuel. But remember, your answer should not end only with this number. This is the amount of heat given out, heat energy. And how do you know? It's a kilojoules here. Okay, if you want to write a calorific value, you have to write this unit. So you have to remember this. We'll end this video here. Take up few more questions in the next tutorials.